Hello, my name is Ardi and we are going to solve practice exercise 3.3 from Morris and Mano book. So the question is simplify the Boolean function fxyz is equal to sigma 0, 2, 3, 4, and 6. So probably let's take a note here that we can convert that index here of the min terms to the binary. Because we have 3 variables, we need to convert it into 3 bits binary. So 0 is, I think to get it more formal, let's write it like this. Decimal and then binary. Okay. So if we have a 0, we will have 0, 0, 0 as the 3-bit binary. And then for 2, we will have 0, 1, 0. And for 3, we will have 0, 1, and 1. And then for 4, we will have 1, 0, 0. And then lastly, for 6, we will have 1, 1, 0. Okay, now let's draw the K-map for 2 variables. So I usually draw it like this. So xy is this one, and the z is the column there. So let's write the rows first. The xy is consists of 2 bits, so we'll have 0, 0, 0, 1. And be careful here, this is not 1, 0, but 1, 1. And finally, this here is 1, 0. And for z, because there is only one variable, we only have 0 and 1 here. Okay, now we have 0 here, and we can write it 0 as 0 here. 0, 0, 0. This is x, y, and z. So x, y, and z, 0, 0, 0. We have the value of it as 1 here. This is for the first one here, the index 0, the min term 0. Okay, now for 2, we will have 0, 1, 0. We have 2 here, and we will have 0, 1, 0. 0, 1, 0. So this is the part where we put 1 here, because this is the min term of 2. Okay, now let's find out 3. 3 is 1, 0, 1, 1. Okay, so we'll have 0, 1, and 1. So for 3, we will need to input 1 here, because this is 0, 1, 1, which is 3. Okay, now we will have 4. 4 is 1, 0, 0. So we'll have 1, 0, 0. Okay, so we need to put out 1 here for the min term for this one. Okay, and then finally we need to find out 6. 6 is 1, 1, 0. 1, 1, 0. 1, 1, 0 is here, so this is the one here. And then for the rest of it, we can plug in 0 here. And now we can circle the ones that is adjacent. It can be only 1, 1, or 2 ones, or 4 ones, or 8 ones. So we have 4 ones here, and we can actually circle of this. Okay, and then we can also circle this one here. However, this one here has a neighbor here that is adjacent. We can actually circle the adjacent one like this here. Okay, why? Because we want the circle as big as possible. So we can actually circle multiple times as long as the circle gets as big as possible. Okay, so now let's get started with coloring with the yellow one here. This part here, this is 1 here. And if we see the X there, the X has different parts, which is 0, 0 here and 1, 1 here. That means that this part here does not depend on x. Okay. And for the y, it's also all different parts here. So it does not depend on y. So that this yellow part here only depends on z. So let's write that. So we will have f is equal to z. However, the value of z here is 0. So we need z naught here, not z. Okay. So that z naught comes from the yellow part. Okay, maybe let's draw up the pink part here, which is the second circle. Okay. And for the second circle here, we have this z here is different because 0 and 1 here. So the z is different. So this does not depend on z, but only depends on x and y here. Okay, the x is 0 and the y is 1. So we need to negate the x. So we will have x naught and y. Okay, and that comes from the pink part. Okay, and I think that is the final result that we are looking for. Okay, yeah, I think that's all for this problem. See you in the next video. Bye bye.